Alright, so thanks to one of your lovely classmates, we are going to do a quick semester review. FYI, I'm not going to be doing too many examples in this video, just going to be going over some quick things you need to know for your test tomorrow. First thing, Unit 1, we went over expressions and equations and inequalities. One thing we talked about is the distributive property that you see here. Multiply the number on the outside times each of the number on the inside. Simple. We also talked about combining like terms. Here we combine 4a with 2a because they both have a. So that gives you 6a. You can combine numbers, so 5 minus 3 gives you 2. Simple. Can you combine 6a plus 2? Absolutely not. Do not write 8a. We also talked about inequality symbols, greater than or equal to, less than or equal to. That definitely comes in handy when we do domain and range in the next unit. Don't forget that these two over here are open circles. These two over here are closed circles. Also, the large number goes over here and the smaller number goes on this side. The large number is on the open side. So if we were to read something, it could say something like 3 is greater than 2. Or you could write it vice versa. You could say 2 is less than 3. And I'm writing on my computer, so don't judge me. Okay? So that's how you write inequalities. Very simple. Solving equations is what we have over here. Don't forget the 5 steps that we learned to solve an equation. The first step is distribute. Second step is to combine. Third step is to move variables to one side, move everything else to the other side. Last step is to multiply or divide. So using those steps, looking at this example, the first one says 2. We have a 2 outside of our parentheses, so we distribute. 2 times x is 2x. 2 times 2 is 4. We are also combining on this line because 15 minus 9 gives us 6. So we distribute and combine at the same time on that one. Then after that, we need to move all of our variables on one side. So we move the 2x to be on the same side as a 3x. When you move it, it goes from positive to negative. 3x minus 2x is, there's an imaginary 1 right there. So 1x plus 6 equals 4. You subtract 6 on both sides, you end up with x equals 2. And remember, you can plug this back in, double check your work, all that good stuff. The same thing happens if it's an inequality. The only real difference is, one, our symbol will look different. So let's say we had a less than symbol instead. So let's say that said 1x plus 6. Oh, that is a variable. Let me try that again. Let's say that says less than or just less than. Okay. And let's say that x is negative 1. There's a negative 1 in front of that x. Like I said, the only thing that's really different with inequalities is, okay, so we would have subtract 6 down here and cross that out. That's the last answer. So on this side, we would end up with negative 1x. On this side, we would have less than 4 minus 6 is negative 2. Now, to get rid of that negative 1 in front of the x, we need to divide. But notice we're dividing by a negative. Here's the only thing that's different with inequalities. If you divide by a negative, that symbol that we have, it flips. So instead of it saying x is less than, it's going to flip and say x is greater than. So x is greater than negative 2 on that. So the same 5 steps used to solve the equation. The only difference is that with an inequality, that last step is kind of different. So just be careful. Next, our next unit, we talked about functions. We talked about continuous and discrete. Remember, continuous does not mean it goes on forever and ever and ever. Continuous means that those two dots are connected. Continuous, connected. Discrete means those dots are disconnected. So discrete would mean we just have a bunch of dots on our graph, not connected, just random dots. Those are really good dots, Miss James. Thank you, I know. Okay, so this function that we have here on our graph, this is continuous, which means we would write it like this. And this is not the actual numbers. We're going to write the correct numbers, but that means we're going to use inequality signs. Whenever you have a graph that is continuous, it uses inequality signs. If it was discrete, if it was all those little dots, it would look like this. This is how you write it for discrete. So on an answer choice, it's easy to eliminate it's easy to eliminate domain and range. First, look at the symbols. Are the dots connected? If so, they need to have the inequality signs. If they're not connected, then you just list it out as you see here. Domain and range. Here's how we talked about solving domain and range. First thing is you're going to draw a box around the entire graph. You're trying to box it in. We're trying to find the smallest x and y values. And remember, my lines aren't straight. I'm writing on a computer. Alright, so for our domain, I'm only going to do domain. You can find out range in your own spare lovely time. So for domain, Jesus Christ. Domain is the x value. So I'm going to look at the x values here. This is the x value that I crossed on the x-axis with that box. This is also the x value that I crossed on the x-axis in that box. So for my domain, my smallest x value is negative 3. We have an open circle there, so our symbol looks like this. X goes in the middle. And our biggest x value is 1. We have a closed circle there. So when you write your closed circle, you put the equal to sign underneath. You put the line underneath. So that's your domain from -3 to 1. We're not including -3 because it's an open circle, so no line underneath. But we are including 1 because it's a closed circle. You would do the same thing for your range from -4 to 0. Is it a closed circle? Is it an open circle? Okay. Relation and function. We also talked about whether certain graphs or tables or relations of functions. Remember, you're looking at the x values. So if they give you a graph, it's pretty simple. Draw vertical lines. Is that a function? Yes. How do you know? Because I only pass through the graph one time each time. Okay. Now, don't judge, but let's say they gave you that red circle. Is that a function? No, Miss James, it's not a function because when I draw a vertical line through that red circle, bam, I crossed once, twice. That is not a function. If they give you a table, make sure you look at the x values only. Same thing if they give you a map, you're only looking at the x values. I have a video for function notation that I'm going to show you in just a second. Alright, so here's how you can use the calculator to help you with function notation. Go to add a graph. Go ahead and type in the function that they give you. Press enter. A lot of people like to use trace. That is fine. But if you use Control-T and pull up the table, here's an easy way to do function notation problems. For example, they say find the range when the domain is 4. So when my x is 4, my range is 11. Simple as that. Or they may say find the domain when the range is -7. So when my range, my y value is -7, this is my range value. Alright, this was a very important unit. We talked about linear functions and inequalities. This is where we talked about slope, our m value, which is our rate of change in y over change in x. We also talked about y-intercept, is the initial value, which is b. Our x-intercept, the calculator calls a 0. All of these you can find on a graph, you can find them on a table, you can find them in a calculator, however you want to. On a graph, this point where we cross the y-axis, that's my y-intercept. That's where I'm going to start. So my y-intercept is at 2. My slope is just how did I get from one point to the next point. So I rose up 1 and I went to the right one. So when I write my slope, it's 1 over 1. My x-intercept on this problem would be -2. My x-intercept is where I cross the x-axis. When you write your equation, you want it to be in slope-intercept form. The only thing you need to plug in is m and b. M stands for slope, b stands for y-intercept. Standard form is pretty much the same thing as slope-intercept form. The only difference is that you need x and y to be on the same side. So you need to move this mx to be on this side, and bam, you're in standard form. Point slope form, we didn't practice that very much, I apologize, but point slope form is where they give you a point and a slope. You plug them into this lovely little formula down here for y1, x1, and m. You plug those values in. You get the y's from the y, x and the y from the point. You get your slope. Either they give you your slope or they give you 2 points and you can still find it. You plug all those values in and bam, that's point slope form. The next video that you're going to watch is going to show you how we can get the slope intercept form of the equation straight from the calculator. When you're trying to find a slope intercept form of an equation, you go to add list and spreadsheets. Next to A you put x, next to B you put y. Don't enter anything on that gray line, then you enter your value 0, 2, 4, 6. Then you enter your y value 0, 3, 6, 9. Go over to a blank box on the right, you press menu, you go to statistics, stack calculations, and always press linear regression that has the mx plus b. Next to x list you put x, not double x. Next to y list you put y, you can hit enter twice or go and press OK. Here they give you the m and b value. This is your slope, this is your y-intercept. You plug them in, y equals mx plus b. But only after you check and make sure that r squared is equal to 1. Also, don't forget that step. If r squared is not equal to 1, that means this is not a linear function and we need to try something else. But on this one, r squared is equal to 1, so that's how you write your equation. We also talked about applications of linear functions or real-world problems. For example, a taxi company charges a $4 fee plus an additional $2.10 per mile traveled. The function f of x equals 2.1x plus 4 represents this relation. If the taxi fee increases to $4.25, what characteristics of the graph of this relationship would increase? So here, this $4 fee is what we're paying no matter what. That's our initial value. That's our b. That's our y-intercept. $2.10 per mile. Remember, when you see that word per something, that should automatically remind you of your slope. So here we have $2.10 per mile, so that's our slope. And the problem wants us to increase the fee, increase that initial taxi fee to $4.25. So our slope is not changing here. The only thing that's going to change is our actual initial value. So if we were to make a quick sketch of that graph, bam, there's our first line for our initial values. But if we were to draw that second line with the increased y-intercept, the line would look very similar. The only thing is that it's up. Remember, our slope did not change. Our point where we crossed the y-axis just went up. It increased. Those two lines are parallel because they had the same slope. Remember, parallel lines have the same slope. This example is pretty simple as well. Systems of equations. The hardest thing was setting them up. Remember, the calculator does the work for you. So if you take a look at the example, we're dealing with pencils and pens. I'm going to label pens as X and pencils Y. So I have 8 pens, which is 8X, and 7 pencils, which is 7Y. Gave me a cost of $3.37. And then I have 5 pens, and so 5X plus 11 pencils, 11Y equals $3.10. And remember, your cost is your total. That's where the equal sign comes in. Once you set them up, the calculator does the work for you. All you need to do is go to Add Calculator, press Menu, go to Algebra, solve system of linear equations. We only have 2 equations, and our variables are X and Y. You could change your variables, but then we would have P for pens and P for pencils, which wouldn't make sense. So leave it the way it is. So then you just type your equations exactly how they look. 8X, 8 pens and 7 pencils gave me a total of $3.37. 5 pens and 11 pencils gave me a total of $3.10. Type in both the equations, press enter. Now it's important, remember, this is not your answer. That whole thing is not your answer. The question says how much was each. So you have to remember, what did we label X as? X was pens, so each pen cost me 29 cents. Y is pencils, each pencil cost me 15 cents. So make sure you answer the question when you get the answer. Lastly, unfortunately, we did not get to cover a lot of the laws of exponents. I know, I'm sorry, we're gonna take an L on this one, but it's okay. We'll catch back. The laws of exponent powers, they're actually all on your formula chart. So if you use the chart, try to figure it out. It's not that complicated, but I know that we didn't get to cover this before your semester exam. But let me just talk about it very briefly. For the power of a negative exponent, and anytime you have something raised to the negative power. So here, this A is really over 1. We've already said that. We already know that. It's imaginarily over a 1. Because it's to a negative exponent, we're going to flip it to make that negative exponent become a positive. So it's negative exponent. I'm going to take it and move it to the bottom. Because it was on the top of the fraction, now it's on the bottom. When I moved it to the bottom of the fraction, my exponent went from a negative n to a positive n. Okay, so if it is a negative exponent and it's on top, you move it to the bottom. If it's on the bottom and it's negative, then you would move it to the top. Very simple. Okay, power of a power. Power of a power means that when you have a power raised to a power, you multiply. For example, I don't know how good this is going to look. X to the 4th. If we had x to the 4th and we squared that, or cubed it even, let's cube it. That just means we're going to take those two exponents and multiply. It's going to come out to be x to the 12. Good. That's it. Power of a power. The power of a product, pretty much the same thing. The only difference is, let's say instead of just x to the 4th, we have x to the 4th y squared. All of that is raised to the 3rd power now. So the only difference is now instead of just x, we have x and y. So what this rule says is you not only multiply it to the x exponent, but you also have to multiply it to the y exponent. This goes back to that property we learned a long time ago, distributive property. Take that exponent, that power that's on the outside of that parentheses, and multiply it to each of the powers inside. So I'm sorry, baby, I'm going to have to write on your face just a little bit. It would look like x to the 12. We already know that. But then it would look like y to the 6. 2 times 3 is 6. So that's all that one is saying. It's the same thing as the one above. It's just now there's more than one you're multiplying it to. Okay. Power of a quotient, not much different than what I just did. Up here, let's say we have I don't know, 1/2 raised to the, I can't even see what that says actually. We actually don't need this rule. I don't even know what this rule is saying right now, so we're going to cross this out. I can't see that far, or it's kind of blurry. Our quotient rule is down here. Sorry. A to the m divided by a to the n is a to the n minus n. So what does that look like? X to the third divided by x. Now remember, this x on the bottom, even though we didn't write it, it's an imaginary 1 right there. So this x is to the power of 1. All this rule is telling us is that if we have x cubed over x to the first, you subtract. So what's 3 minus 1? 2. So x squared. That's all it is. And product of powers, this is the one we actually have done in class. X squared times x to the fourth. How many x's are we multiplying all together? X to the 6. Okay, I know it sounds confusing. Do not try to stress yourself. If you want, if I were you, I would go maybe YouTube some videos, go look at a lot of these vocab words and stuff that we talked about. If you want to YouTube some laws of exponents videos just to get some extra practice, you can. Good luck tomorrow. I know you got this, and we'll work on it.